Morning, everybody. So today we have kind of nuts and bolts, meat and potatoes lesson. So we're going to look at what's probably the most important mathematical process in science, and that's converting one unit into another. So to begin with, we got a little warm up here. So I've given you a question that can be solved using this dimensional analysis process, and it involves kind of relates to what we were looking at in the last class with the lab. So I'm going to read through this. So we have a chemist here that requires a certain amount of individual atoms. So remember, we've talked about chemical reactions at this point and how the chemical equations that we see are really recipes. So they tell us what ingredients go into the reaction and they tell us what products, what's made with those ingredients. And just like recipes, every recipe requires specific ingredients and specific amounts of those. So the chemist needs to be able to count out, quote unquote, count out the correct number of atoms. So here in this particular example, a chemist requires 3 times 10 to the 23 individual neon atoms. So how's this chemist going to count this out? So this is the problem that he has, and we have a little conversation with the Migas maestro here. So you can read through that. And then here's the key, right? So this right here, this is a special number, 6.02 times 10 to the 23. It's called Avogadro's number. So this is a standardized number of atoms that chemists gave a certain specific special name, and they named this number of individual atoms the mole. So the mole is equivalent to the unit dozen. So if we talk about eggs, you buy eggs in a dozen. That simply means that you have 12 eggs. The mole is the same thing as a dozen. It just represents a different quantity, and it represents this quantity. So if a chemist says they need 1 mole of atoms, it means they need this number of atoms. Okay, so that's what we got here. So I have a couple of questions to walk you through and see where we're at on this. So again, this has to do with measuring out this number of atoms. We can't count this, even if we could see atoms. To count this number of atoms would take many lifetimes, such a gigantic number of atoms. So we can't count those. One, because we can't count atoms because we can't see them, and two, because there's simply not enough time in somebody's life to count that number of atoms, let alone do it all the time. Okay, so we have to count those atoms by mass. All right, so that's what we're going to be looking at, and everything we do the rest of the year will be using this. So there's an easy process to turn a number of atoms into a mass of atoms, and back and forth, and so on and so on. And this is using a process called dimensional analysis. So for our activity today, what we're going to do is we're going to do some practice on dimensional analysis. So this is the hardest thing for most students, and it was for me. So over time, just like the math steps, I developed a set of processes, a set of steps that you follow that will allow you to set up dimensional analysis problems. And that's what we have here. So these are the notes. So you can download these, right? Or if you click on there, you can download it. Go into our Teams tab here. You can go into the General tab, into Files. Click on here, day 27. You can click on here too and download the stuff here. So we got the same work in there. Right, so this first page here, 926, we got the steps. Okay. Now here I have a lecture. So these are the practice questions I used in the lectures, you can see, and then here I have lectures with me using the steps to solve dimensional analysis problems. And here's the practice work we're going to do today. So you can write directly on this, and I've already sent a copy of this over into your folder there. So that's what we have there. And then the exit ticket, what we're going to do is we're going to go back to the warm-up, and we're now going to see if it makes any more sense than it did. And so that's what we have today.